starting?
We are starting. Oh my god, my microphone's all the way in the sky.
All the way in the sky.
Hello.
Hi.
Hi, chat.
Hello,
How's it
chat.
going? I did change the title. It was just a little bit late. It was a little bit hectic trying to sort some stuff.
I moved up the title correctly.
Yeah, it's fine.
It's heavily confusing for the YouTube people because
Yeah.
it should be correct.
Yeah, they don't need to worry about titles. Welcome to what episode are we on? Six? Been a while.
It's been a while for us, not for you.
Yeah, I need to turn you up a little bit, I think.
Mm-hmm.
Is that better? Talk?
Hello, hello.
Yeah, there we go.
There we
Good.
go.
Nice. Hello.
I said some really funny things.
Yeah, it was hilarious. Welcome to episode 6.
Episode 6.
Episode 6.
It's been a while for us.
Yeah, we had some problems with streams. We've contacted people, smart people.
Smart people.
Look at the networks, but if you've been following on YouTube, you don't even know about that.
Good.
Yeah, ready to go?
Are you ready to go?
I'm ready to go. What are we doing today?
We're fixing some problems that occurred in our last episode.
Cool.
Or some people might have seen a problem going on. And this is going to be a very slide-heavy episode.
We learning today.
We're going to learn today. But we're going to practice in between. And then in the next episode, we're going to apply it. So we're not going to apply what we learned today to the game, because it's a lot to cover, and I felt that it would be too much, and I wanted to focus. And we have many episodes to go, so it's fine. So today we're going to focus on those topics, and then in the next episode, we'll apply those topics.
Sweet.
Ready?
Good. I'm ready.
I'm not, but let's go.
I'm going to go to your screen.
My screen.
Nice.
Hi, Gabe.
Hello.
Last week was fun.
It was fun. It was good.
I wasn't here, but last week was fun.
Yeah. The day we recorded 2 streams in a row was fun. Why am I so small? I'm very small in the camera.
I don't know.
Not this small.
I don't know.
Fake news.
Fake news.
Yeah.
So now it's time to learn new things.
Yay.
Plural.
Yes.
Plural.
Oh, I can't even learn one thing.
Yes, you can.
Yes. Well, we'll try.
Who here watched the last episode and liked your wee? That was an epiphany, and I like those, because that meant that not only did you understand what was going on, you could apply your knowledge to mess with the code and then see the reactions. Like, oh, if I do this with the code, I think this will happen, and it worked. Which meant that your mental model was correct regarding the thing we were doing.
Nice.
And that's important.
I did something right.
In many cases, it's going to be a little offset, and that's why we practice to mold our mental models. But it's great to see the model working. And with those new things, we're going to open up a whole new world of stuff.
A whole new world.
A whole new world. There's a movie that does this, I think. So, let's go.
Let's go.
Let's talk about variables.
Let's do it.
So the idea with a variable is you're storing something. You're storing a number in a container, in a box. You can also make a variable out of a class, which means that it's storing more than one thing. You're grouping variables together. And then, of course, a class can group other classes. So you can have like this hierarchy of groupings together. But let me highlight the problem that is going on here now. Because we've only used variables. So one variable is storing one number. We've used conditions or questions, one if statement, which is asking one variable, or in some cases we've been asking many variables. And then we have functions, which does one bit of code. But we want to have many enemies on screen. We want to shoot many bullets. We want to have many walls to collide into. So let's create a hypothetical. We have some variable that is storing the student's age, some student, and it's the age of that student. And the age is 10. So it is a number, it's 10. And like we learned last time, we infer the meaning. There's some person there, and the person is of some age, and that age is 10. For the computer, it's just the number 10, nothing else. But we infer the meaning. Great. And if it's a new year, let's just say we have some way of doing this. If there's a new year, what do we like to do with the student's age?
Bring it up one.
Bring it up one. So we say the student's age is equal to the old value in student's age plus 1, which is then 10 plus 1, which is 11, and then 11 is stored into the student's age. Great. We've gone over this. This works fine. And we've done a lot of stuff with just this idea.
But in this scenario, we would need something else saying what New Year is.
Yeah, let's imagine that exists somewhere and that works, and that's great. So for this example, it doesn't matter, and let's say that's a great system that works well, yes. However that is.
Well, but that's I hope so. Time works well.
Time.
We talked about that very briefly. Time is some very, very complicated.
Time is very complicated. So okay, great, and we've done a lot of cool stuff with this. Like we've done collision. Like we've done collision with stuff like this. It's simple building blocks.
It was literally blocks.
It was literally blocks. Literally blocks. And we saw when we created 2 boxes that we had to ask the question twice. And we had to repeat a lot of code twice. And I briefly mentioned in that episode that it's a problem, but we'll deal with that later. And now's the time.
Oh, snap.
Now's the time.
Now's the time. A whole new world.
A whole new world.
Whole new world.
So if we have 2 students, we'd have to do something like this, right?
Yeah.
We have to say student age, okay, it's the first student. That student is 10, sure. Second student, 2, okay. That student is 11, okay. But now what? So if New Year, what do we have to do?
You have to do 2 of them.
Yeah, so student age 1.
Age 1 equals student age plus 1.
Yeah.
Student age 1 plus 1. And student age.
Okay. So we have that now. Cool. So let's say we don't have 2 students in our class. Like we have 5 students.
Yeah. Or 5. 55, same thing.
Yeah. And then we have to ask a question.
We just have to ask the same thing 5 times.
Yeah, this is, as programmers, we're lazy. I don't want to do this work. And yeah, you're right. We have to do this thing 5 times. And did you notice the bug?
No.
There's a bug in this code.
Hold on.
Yeah?
There's age 3 and 4.
Yeah.
Yeah, they're mixed.
Did you notice it initially?
No.
No. Which is like...
I can count to 5. 1, 2, 4, 3, 5.
Yeah. So copy-paste mistakes like this can happen. So last class we learned about classes. Is classes going to fix that for us? Well, no, because a class encapsulates 1 object. So that's still going to be student 1. That student is we're going to put into the constructor the number 10. That's going to do the thing we learned last time. And then we have to have 5 students. We have to create 5 objects. So problem not solved there.
Just bring my chair up a little bit.
And we want to ask the question, like, okay, is it going to solve the problem there?
Probably not.
Well, we're going to increase the number, and let's say there's a function that called increase age. I think it was, yeah, increase age. So we do that one, but we still have to do all 5.
Yeah.
Did you notice the bug?
There's 2 2s.
Yeah. Like
there's no 4.
There's no 4.
Make 2 plus 2 is 4.
2 plus 2 is 4.
Minus 1, that's 3 quick math.
That's also a song. We're very sing-songy today.
Great song. My favorite song.
So this is a problem. If I want to have many of something, I have to...
Imagining trying to do this for like...
thousands of objects.
Basically just like bending an arm. And maybe in the amount of like points that you have to...
Yeah, imagine you would have a 3D model, and each point in a 3D model at the end of a triangle is X, Y, and Z, which is 3 numbers. It's 3 variables. And then having millions of those.
Yeah. Or I was even thinking, because Olaf is making his game.
Yeah.
It's not you, this is Olaf.
Yeah.
He's making his game, and there's a bunch of enemies flying on the screen, so you have to do 1 per enemy.
That's a lot of code. And I don't want to write that code. I want to write the code that just does it for me, because that's what a computer is doing. It's doing work for us, and I want the computer to do this work for me. Right? Great. So the concept is called...
spoiled it for me. I knew this was
It's okay. So the concept is called an array. And so let's go over how an array is defined. So an array is a collection of variables of fixed size, and that's the fixed size is the collection, not the variables. So how many variables we have is fixed. Yeah. They are created in memory, one after another. The same way we're doing here, or it's more like this. If I would have an array of integers, an array of 5 integers, it would be like I did that. So again, we come to our last concept, which is the abstraction, which is to wrap a concept into some idea. So they are created in memory, one after another. And you cannot change the size of an array. There's ways to do that, but we're not going to learn about that right now. So you cannot change the size of an array after you have created it. That's good. So it's the array is a collection of variables. It's just a grouping, like the classes is doing. The array is a fixed size. They are in memory one after another. And
so a fixed size just again is just like if this contains 50 things.
Yes.
Okay.
And you cannot change it after that. And then it would be like if you say I want to create 50 integers. In memory, there will be one after another 50 integers, like int. All right? And you cannot change the size. So when we have this, student age 1, 2, and 3, we want to have an array of 3 integers. So how do we define an array? So we would like to have an array of integers. So we first define that the type is an integer. Like we did before, when we create a variable, we say int. But what we do especially is that we do this. The 2 brackets.
New brackets.
New brackets.
Uh-oh.
2 new brackets.
Uh-oh. More fumbling on the keyboard for me.
More fumbling. Oh, I fumble too. So this is just saying, this. If you imagine a good way to think about it is, it's a box which is of some size and it contains your integers. That's one way of thinking about it. Then you just say the name of the variable, just like before. No difference there. So if you think of it from a regular variable's perspective, the difference would be just the brackets for now. All right? And then you say new int, brackets again, and how many. You see that the number of integers is not in the first part, but it is in the second part. Because we don't need to know how many they are after we create them.
So what happens when there are students of different ages? Because wouldn't this say create just 3 student age? No. So
here's the thing. So yes, it creates 3 integers in memory, one after another, and the array is called student age. So that's the point here. The array variable is called student age, and the array contains 3 integers. Like the class contains variables and functions, the array contains the variables. And they have to be of the same type. You cannot have, in this language, it's possible in other languages, but we're going to keep it simple now. You cannot create an array of mixed types. So you cannot say, oh, I would like an array of, like the first 2 should be an integer, and the second 2 should be like a Boolean, and the last one should be like a text. Like, no. You create an array of the same type, exact same type. If you would like a collection of stuff that is like various stuff, we learned about that last time. That's the classes. Here it's the same thing. So this is the integer. This denotes that it's an array. So it's an array of integers. Let's then say we have now these 3 variables. We would like to put a number in it. Because for now, we've just created 3 integers. And we would like to put our number, how old the students are, into it. And again, we use the brackets. We put them there after the name of the variable. And we say 0.
They're 0 years old.
No.
Damn it.
No. So here we are referencing the first integer. So in many languages, arrays start at 0. So 0 is the first element in the array. And then we can say 10. So if you think of this, student age, that variable is an array of integers. This whole thing, student age bracket 0 bracket, is an integer. And it's no different to any other integer we have created before. It's just a way to go into the array and fetch the 0th number or the first number or the second number. So we can do this. This would set all 3 values. And you can use student age bracket 0 like any other variable. You can assign to it, you can pass it into functions.
But it will know that student age bracket 0 is 10.
Yeah, it is an integer, and it's storing the value 10 the same way that the variables we created in the other PowerPoint page created a variable with the value 10. So instead of us putting the number of the thing in the variable name and whatever, we can have one simplified name, student age, and then then just to access that variable within that grouping, we can say which one we want. But do remember, there's no difference between student age bracket 0 and then any other variable. You can assign to it, you can pass it into functions, you can use it in classes, you can create arrays in classes. A class could have an array of things. You could use that as a value when you're adding. So you can say like, what is the sum of all the ages of all our students, which would just be a normal integer. And then you can use the array. This is called an array subscript. Okay. Oops. There we go. So like with int, we can use classes. You can create an array of classes. So here we can have an array of the class student, which would be that we have students. So here we're creating 3 students. And then
here we created 3 students.
Yeah, we spawn them out of thin air. And so like with the integers, we can just say 10. And like we learned with the classes, we have to say new to the class. Like here with the array, we have to say new when we create one. With the students, we have to say new to the student. Because students bracket 0 is just a student. There's no difference there. It's just a way to access the underlying variable, and the same thing here. So here's a pattern in that case. So let's try this out. Let's go to open processing. I have mine open here.
Swap to the dual view. To code.
So we are using, there's a lot of commands for the stream. We're using openprocessing.org. It should also be openprocessing.org/sketch/create. And there should be links as well. I see people are posting some links. Great.
Just waiting for my my screen to wake up. For some reason, it just doesn't want to wake up.
Okay. Let's go to full screen until you have fixed that. Let me do
I don't know what's happening. I will investigate.
Yeah, look at that. Well, I can look at this. So when we have the code up, let me make the font even bigger so we can, because I'm going to write a lot of code. There's one fun trick we can do with processing, and that is we can print out things. So we don't have to write entire programs to find out what's going on. We can just print out things to the screen. So what we can do is there's a function that we have written a few times before called setup. And that function is only going to be called once. I'm also going to create I'm not going to use draw I'm going to hide it like this because it's not going to be used right now. Hey, you're back.
There's something there, but it's not configured correctly.
Yeah.
We'll just do something like this for now.
Yeah. There we go.
We had some issues before. I will attempt to fix it. I don't really know what I'm doing. What audio? Something changed audio?
Hello, hello. Seem to be there.
Do we have someone? Monka S.
Inception audio.
That is strange. That should not be happening. This is very frustrating.
Is it okay now though? It's fine now.
Fine
okay.
Now?
Okay.
I don't know what happened. Oh joy.
Oh joy.
1 second, everybody. Sorry. Let's just try to fix this. Basically.
Good.
I think we might end up just having to use your screen.
It's okay.
If that works.
It's okay. We're not.
We'll just swap between you and me.
Let's have it like this. It's fine. We're gonna test things in a quick way, and then we're going to like go back to the slides, learn more, and then test it again. So with the setup, I can do println and say hello, for example. And if I run this, and if I change my screen a little bit, I can ignore that, just so you can see it.
Hello.
Here we have a hello. And our little box. There we go. Can I zoom in a bit? There was a problem where if I zoomed in too much, it would... There we go.
You always make the text bigger in the text field.
Yeah, not that one, I think. But there we go. Now it goes away. Okay. So the setup function is going to be called once. So I'm going to print to the screen the text hello. I can also print the number 5. So I have the number 5 over here. Yeah, it's also my favorite way to debug. Just print everything. It's really good. Really good. So if I create a variable here, let's call it Gabe. And it has the value of 5. So Gabe is 5.
I'm 5.
You are 5. Not in age, but I can then say print Gabe, and I would get again the number 5. But if I would like to have many Gabes, because who wouldn't want to have many Gabes around?
Many people.
Many people. I would like to say new int, and let's create 3 Gabes. It prints out 0, 0, 0, because this is the list. And if I say I want to have 30 Gabes,
just gonna print it 30 times.
Yes. And then I can say, oh, after I've created these 30 integers, I want to say Gabe, let's say, give me a favorite number.
6.
6. And that is the number 87. All right?
Now the 6th one is going to turn into 87.
Is it the 6th one or the 7th one? Because we start at 0.
Yeah, so it would be the 5th one, wouldn't it?
There we go.
Why is it 7? Oh, yeah, never mind. I'm really
Other
dumb.
way.
Yeah, I was thinking the wrong way around.
Wrong way around.
Yes, it's the 7th. I'm go back to 5. That doesn't even make sense. Yes, got it.
Yeah. And then what I can do is I can say, oh, Gabe number 6 is the number 87. Gabe number 10 is the number 107. And then I can say Gabe game number 29 is Gabe 6 plus Gabe 10.
Oh, snap.
Oops. There we go.
Nice.
So you can see I'm using these just like integers I did before. I set the 6th one to 87, the 10th one to 107, and the 29th one to be equal to the 6th one and the 10th one. So here we go. Then we have 87 over here, 107 over here, and the last one, which is the 29th one, to 194. So if I try to do that, the 30th one,
you just go, no. Oh, it still signed it to the last one.
Let me see. I think it's running from the old one. Let me see. Let's do this maybe. Well, maybe the language doesn't have the error checking for that. The 31st. Here we go. None. not the number. Seems the language has some checks for this. Other languages would flat out just say, no, you cannot do this. I'm not gonna run this for you.
I'm not listening to you.
Exactly. Exactly. There we go. So back to this. We have 194. There's a common joke with programmers that the hardest problems in programming is blah 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 and off by one errors, where you're correct but you're off by one number. And this is
I feel like I'm gonna run into that problem a lot.
Yeah, especially when you don't have the number directly, but you have to say how many things are in the element -1. And if you forget to do the -1, then you'll get the number 30. Because if I say Gabe number 29 is Gabe.length, and I run that, I'll get 30 here at the end.
What's length do?
So length is this number. And this is why, one of the reasons why I waited a little bit with teaching arrays is that if you would see a variable, it's an int, it stores an int, these are just ints, and then suddenly we have this, you'd be like, how does that work? But how did we access...
Which is exactly what I said.
Yeah, how did we access variables within a class in the last episode? With a dot.
Yeah.
We said dot and then the name of the variable. So this harkens back to that.
And length is just the word to take into account the maximum value of whatever number you've given it.
Length is a variable. It is an integer like any other, and it stores that number 30 we put in. So if I go and change that one to 20, and I do here 19 to offset that, I haven't changed this one. It would say 20 here. All right.
Yep.
So we have our Gabe length.
Our Gabe length.
We have a long Gabe.
Long Gabe. I moved my mic a little bit closer.
Yeah.
I'm also talking like away from the mic, so that might be it. I'm gonna just shuffle over here, so it's a little bit better.
I tried to do it like this, so I'm talking like towards you and towards the mic as well.
When you like just opposite mount them on this.
Mm-hmm.
I can turn the mics up a little bit. So.
Yeah.
Cool.
But there's still a problem here. Okay, let's say that we have a class called enemy.
Enemy.
And we would like to create an array of enemies.
Yes. Yes.
And we would say enemies. And we would then say, we have an array of enemies. That variable is called enemies. We would then say new enemy. How many? We want
40 million.
40 million. 40, 3, 4, 5, 6. We have 40 million enemies. I don't know how well this is going to work, but anyway, we have 40 million enemies.
We can't take it back now. They exist.
They exist. Well, after I run this, they exist. I'm wondering what happens if I do this. Nothing.
Absolutely
nothing. It doesn't like it. Let's do... For our beta test of our game, let's have 400 enemies.
A little bit more of a reasonable number.
Reasonable number. Gabe's not defined. That's okay. Because who could define Gabe? That would be impossible. So, great. We have this functionality. We can very fast and very easily create a collection of things. But I still have to do this. Enemies 0 is new enemy. Then we put in some stuff because it's a class, whatever we have to do. And then I say enemies 1 is new enemy. Something else. You see the problem here now. I have to do this 400 times.
Yeah. It doesn't sound very fun.
It has solved one of our problems, where I can create an array of a class that I've created. The class has a nice interface, it's well defined, we are happy with that one. But if I want to create those 400 enemies, I have to do this by hand. And that's no bueno, not cool.
How do you, what? How are we going to, what? How do you make it not, how do you define something without telling it to define that?
Well, computers are good at doing repetitive work.
I just don't even see how you would tell new enemy, whatever the value that it's storing between the brackets, how I would tell enemy number 4 that is different from enemy number 55.
These are good points.
It hasn't made... Then again, I didn't understand how anything worked before. Now I maybe understand like 2 things.
That's why we're learning.
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 Science.
So let's go back. So we tried it out. We could create an array of things, but we have a problem. We don't want to go through all those things and create them. Loops. Jolly ruthless, you are correct.
Loops.
Absolutely correct. Or as the moth would say, like loops, or how would that be?
Loops?
Who
would say that?
I don't know. I wanted to say it like loops with an umlaut. Loops. So, loops are conditions, like the if, that ask the question and run the code between the brackets many times. So again, we haven't gone away from our concepts. A loop is a condition. So the initial conditions we have that we learned is an if. We can ask one question and we can run the code between the brackets one time. That's it, no more. If you would like to ask another question, you have to either call the function again that has the if, or ask another question. Or we would like to ask many questions. Or we would like to run code again and again and again. In processing, there are two types of loops. In other languages, there are many types. They function different ways. The ones that processing has are used in many languages. So by learning these types of loops, we learn about loops in many other languages. So this might be a little bit more complex because I'm going to have to go through all of them. And we're not going to use one of them. But I have to explain one of them to explain the third one. Like the first one is easy. We're not going to use the second one, but I have to explain it to explain the third one. And the third one is the one we're going to use. All of them. Great. Here's the first one. It's called the while loop. And here's the second one. It's called the for loop. And the third one is also a for loop, but it works a little differently. So it's only while, parentheses, and brackets, and then for, parentheses, brackets. The question is still within the parentheses, and the code is still within the brackets. So there's nothing changed there. So, while. A while loop acts the same way as an if. Like, if you have an idea about an if, you know how a while loop works. But it keeps running the code between the curly braces until the question is asking is false. So let's look at that. So if we are having some fun, then we run some code.
Yeah.
How often will this run?
Once. No. While we are having fun.
Well, this is an if. If we're having fun.
Oh, just run it once then.
Run once.
If we're having fun.
If we're having fun.
If we're not having fun, it's not going to run it.
Yeah. So if we're not having fun, we won't run this code. If we're having fun, we'll run some code. Great. While we're having fun.
Yes.
Yes.
So then it's going to continue to run the code while we're having fun.
Yeah. So if we keep having fun.
That name makes so much sense.
It's like someone thought about this.
Yeah, almost.
Almost. So if we never had fun in the first place, when we get to this line of code, will we ever execute it?
No.
No. Same thing as if. If we have fun forever,
you're going to get a lot of code.
We will run this code forever, right? It will go, if we can use the pointer, it will start here. It will ask the question. It will go into the brackets. It will run the code. It will come down to the bottom bracket. It will then go back up and ask the question again.
Could you do things like while key pressed, run forward?
You're having revelations here, sir.
Yes!
Yes. Yes, you can. So if this is false in the first place, we skip over everything and just go down. If this is true once, it's true now, we go down here. The code here changed this value to say we're not having fun anymore. We still go back up. We still ask the question. Then it's false. We jump over everything. But if it's true forever, we will run this forever.
So in code, if you come across a while and you're running that while, it'll stay there. So basically you could have like 4 lines of code, then a while, and then like 3 million lines below it, but it won't touch the 3 million below it until the while is complete.
Correct. Again, a revelation here. Or, like in many systems, you have some code which is doing some setup, and then you have a while loop, and it stays there forever. And I will show you an example. So here, like some in chat have been talking about, if I just write while true, true is never going to turn into a false because it's a value. So this is an infinite loop. Where do we use infinite loops?
Time.
You're going very existential here.
Do we use infinite loops in time? Does that exist? Where do we? This is gonna be. Where do we use infinite loops? I don't know. Literally the first thing that came to my head was time.
Time? Okay. Will we use them in games?
I mean, the problem is you can close a game and then the whiles ends. So it's not really infinite.
There are ways out of an infinite loop. We're not going to talk about them right now because we don't need them. But
you can cheat and read chat. There's a draw function in infinite loop.
Spoilers. So here's the thing.
Thank you, Felix.
Here's the thing. While game is running, what is game?
Whatever, just a game.
Is it a class or what is it?
A variable?
It's a variable. That's correct. Is running is what?
A class? No.
No. Is it a variable or a function?
It's a function, isn't it? It's not. It's not a variable.
No, it's not a variable.
It's a function.
It's a function. That's correct. Is it a function in game then?
No, it's a function with the. Well, it's a function. Yeah, it's a function with the variable.
Yeah, so it's a function in game.
Yeah.
Which means that game is of a type that is a class.
Yes.
So we can have a.
Oh wait, hold on. That was a confusing sentence.
Yeah. Because with an integer, there's no functions in integers. Yeah. If you make a class, you can put a function in a class. And then to call
game is a function.
The game is a class, and is running is a function in that class.
Okay.
Yeah. So we can ask the question, is the game running?
Yes.
Let's ignore what that means, but let's just say the game is not running.
Yeah.
We would handle the input, we would update everything in the game, and then we would render it to the screen. This is called the game loop. And a lot of simple older games ran like this. Like this is absolutely how they ran.
But you would give it the. Yeah, no, okay, I can see it now because game is the class.
Yeah.
So it knows what game is, and handle input is a function that you've made somewhere else, which will have a bunch more complicated code.
Yep.
But it's all been condensed into this one function that's in a while loop that's just infinitely running itself over and over and over and over.
Yeah. That's a game. A lot of old DOS games do this, where they would just handle input, update the game, render to the screen as fast as they can, because they knew that the computer they were running on was 32 megahertz, because it was the time of the 386 IBM compatible machines, which meant that you would go through this loop at the rate of 33 megahertz. So they would just make their game work well at 33 megahertz. Great. And then someone would buy a Pentium later on, which would be 90 megahertz or whatever, and the game would run faster. The cars would run faster.
Oh yeah, we have that. Recent games without naming them have, when you tie it to FPS,
yes,
some physics run faster. Because someone mentioned something in chat that had me thinking. So here, every time it does a loop is a frame.
Yes.
So in the setup, we're telling 60 frames a second or whatever you set it to. So it's running the while 60 times a second. So the game is running at 60 frames a second.
Yes, this tries to run the game as fast as the computer can. The update can include the physics engine. Yeah, chat knows what we're talking about. So what you would do if you wanted to fix the frame rate is that you would handle the input, you would do the update, you would do the render. This is a simple implementation. There are books on this, like literal books on this. And then after the render, you ask, like, how long did it take me to do this? To handle the input, to update and render? Because I'm supposed to run at 1/60 per second. I should run 60 times a second. Oh, you took less than 1/60th of a second, so there's time to spare. so let's just keep rendering, or we can sleep, or we can, like, there's all sorts of things you can do. Usually they keep rendering, and people don't notice that. And then when that spare time is done, we go back up. Game is still running. Yep. Let's handle the input. Cool. Let's update the game. Yep. And let's render. How much time is left? There's so much time left. Okay. And
does it matter which one comes first within the while function? Because it runs them all down in a list.
Down in a list, yeah.
But I guess that just
matters.
Randomly from like a game perspective, I guess it would matter if
you could probably design a game that does things in different orders if that works for you. It's usually this. It's usually much more like complicated and convoluted with all sorts of things. But generally, this is the idea.
So basically, an entire game just runs in a while.
Yep.
Nice.
Yep.
Nice.
So in handle input, you could say, oh, you hit the escape key. And hitting the escape key turns game is running to false. And then you exit the while loop. Yeah. The game quits. Of course, it's more complicated than that. But I mean, I'm just showing the connections here between these things. So a problem would be that you only want update once per whatever. And other games, there are games like, I think it's StarCraft 2, that does the handle input as fast as it can, renders as fast as it can, but runs update at a fixed rate. That's much slower. Like if the game is running at 60 frames a second, the update is running at like 5 or 10.
Yeah, isn't this something to do with their physics? No, maybe it's not their physics engine. There's something that this sounds familiar. Something about the way that game runs. It handles something.
It's often done with AI. If it's complicated AI, if it's complicated systems that are interacting with each other. A lot of like city builders, like SimCity and whatever, they do this as well. Because
the stream will be uploaded.
Yeah, because users don't notice this. Because you can still render stuff, and animations can be triggering and moving and all that. But the update is changing the state of the game. We can still animate a lot of stuff while in that state. Okay, so that's one type of a while loop. Let's try another one.
Setup.
Here's a function called setup, we're calling it. Someone made a function for us called setup. Does this ring a bell?
Yes.
We have a while true loop. We call draw. What's this?
We're always drawing what's in setup while true.
We call setup once.
Yes.
And we call draw as often as you can.
Yes.
Isn't this...
It's an infinite loop.
Isn't this processing?
Yes. I guess, yes.
Yeah.
Yeah, that's what we do.
That's what we do.
With as I point to my screen.
Yeah.
Because there's a setup and then the draw.
Point to screen.
Point to screen. That's basically void draw, isn't it?
Yeah. But processing has this loop somewhere in its code and just trusts that we create those functions. Processing wants us to create the setup function, and processing wants us to create the draw function. It has this code somewhere. And this is why setup is only called once, and draw is called as often as we can. So before, we always talked about like, oh, the setup and the draw, it's magic in the background.
This is where it comes from.
This is it.
So basically, processing just has this built into it.
Yeah. Okay. Somewhere in the code is something like this. Might not look like this, but this is the idea. So, for loop. So that's while loops. That's it.
I like while loops.
Yeah, they're cool.
It works.
We use them a lot. Yes. We use them a lot. So there are two types of for loops in processing. There's also two types of for loops in C++. There are two types of while loops in C++. One is called a while and the other is called a do while.
Do while?
Yeah, which is you will always run it once, but then you ask the question. That's sometimes handy. So this is going to be a little tricky to show, but bear with me. I kind of have to do it this way. So a for loop has three parts. It has a declaration and a semicolon. It is a condition and a semicolon. And it has a thing called an iteration. And then you close it, and then you have the code. Declaration, condition, iteration. The declaration is run once, and it's run before the loop starts. The condition is run like the condition in the while loop. they ask the question every time.
Like if true.
Yes. So the condition is the same as the while loop. And then the iteration is a thing that happens before you ask the question. Declaration is once, condition is just like the while loop, iteration is after. So you can think of the declaration is happening here before, condition is happening here in the thing, and you can think of the iteration as happening here at the bottom. Like you go through the loop, have your fun, run your code, you come to the bottom. Before you go back up, you run the iteration. You come back up here, you don't run the declaration because that's only done once. You ask the question. If the question is true, we go into the code, blah, 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 have our fun, go to the bottom, we run iteration, we come back up, we ask the condition again and again. So that's how that loops works. So let's create an example. So declaration, yes, I'm creating a variable. I'm calling it I. And this is just like creating any other variable. This is just an int like anything else. It's just there inside the for loop. And then we would like to have some condition. What questions can we ask integers? If they are bigger or smaller than something, right? Okay. So let's ask if I is less than 10. And that's, you can see that in an if, you don't have to say if and then the question. You can just ask the part that was in between.
Because it knows it's a condition.
Yes, because this is the condition part. So it is expecting things like this. So we can ask, is I less than 10? Which is a question we can ask again and again. And then iteration is saying, what should happen next? Here's an example. We can say that I is equal to I plus 1. So what's happening here? What happens first?
Defining an int.
Okay. How often does that happen?
Once.
Mm-hmm.
Yeah, just once. And then
what happens next?
Giving it a condition that if it's greater or less than 10.
Yeah, here it's if 10 is greater than an I.
Yeah.
Is that true in the first case?
No. Oh, yes, yeah.
Yep. It's okay. It's okay.
Yes, 0 is less than 10.
0 is less than 10, true. Great.
So it's true, then I equals I plus 1. So I is becoming 1.
Well, so we do this one first.
Yeah.
That's before anything happens. Yeah. We can think of it that way. This just happens once before anything. Great. Now we have I. Then we ask the question, is I less than 10?
Yeah.
Yeah, it is less than 10. That is true. Great. And we don't do this.
We don't?
Because remember, it happens afterwards at the end.
Ah, okay.
Then we go into the loop.
Okay.
We say whatever the code here is, any regular old code, nothing different there. And then at the end of the loop, we run this. I is equal to I plus 1.
What is a use case for this? Because I can see, so while was not obvious, but you can see how while can be used. How could you use a for?
When you'll see that here is an I, it's 0 in the first place. And then what will happen is I will be 0, and then 1, 2, 3, 4, 5, up until what?
10 or 9.
It will go to 10, but it will never be 10 in the loop.
Yeah.
Because it will be 9 in the loop, great. It will be incremented here. We will go up, we will ask the question, then it's 10 less than 10, no, we will go out of the loop.
Yeah.
Think of this I as the index into the array. Instead of writing 0 ourselves, or 1 or 2, we use a variable. So instead of saying students 0 is new students, we say students bracket I. So we can create all our students here in the loop. We could have 40 million enemies and say enemies bracket I. And we'll try that out in a bit.
So basically, if we set the condition, if we set the condition at 10, it's going to create 9 students.
It will loop 10 times.
Yeah.
Because we start with 0.
Oh, okay. Yeah. So it'll create 10 students.
Yes. So it will create 10 students by writing a for loop and then one line of code. And if we want to create 20 students, we only have to change this number.
Yeah.
The code doesn't change. If you want to create 40 million students, we only have to change this number. The code doesn't change, which is great because we're lazy and I don't want to write more code.
Yay.
then I have to. There's a question, can't you use I++? Yes, you can, but we haven't had the use for it because I++ has, there's a point to it, and there's a point why it exists, and we haven't had to use that point. And when the idea that we're learning here is we only introduce things when we need them. And ++I or I++, we don't need it yet, but it has a point, and yes, you can do it. So the thing is, you can do I++ here, which is the same thing as this. All right. So you loop 10 times with I increasing. So here's the other one. It's a little simpler to explain. So you have a declaration, like we did before, but then instead of a semicolon, you have a colon. And then you have a collection, and that's it. You have a declaration, and you have a collection. And then your bracket is below, and that's all your code. So if I have int student, you see that I don't assign a variable to it. I don't say, like in the last one, I say int I is equal to 0.
Now we just have student.
I'm just declaring the variable. I'm not assigning to it. So I just say int student. What I'm saying is there's going to be a variable inside the for loop that is called student. Student exists in between these brackets. It doesn't exist above, and it doesn't exist up below. The same thing with the I in the other place. And here I say student with an S, where this is an array that I made. So this is an array of students. So if I do, let's say I have a collection of ages. Let's keep the theme going. So I have 2 ages. So the first one is the age 9, and the second one is the age 10. If I then create a for loop where I say int age colon ages, I can say print line age. And what will happen there?
It'll give us just a number.
What will be the first thing printed to the screen?
9.
Mm-hmm. The second thing?
10.
And then what will happen?
Nothing.
Correct. Absolutely correct.
Nice.
Nice. So let's try this out.
Nice.
Did you fix, or should we do it here?
We should do it there.
Yeah, it's fine.
It takes a little bit of manual work that I don't know how to do.
It's fine. We're almost done anyway. This is the last part. And then in the next episode, we're going to use arrays and loops to create a whole bunch of enemies. I want a screen full of enemies.
Nice.
And I want to create a screen full of enemies by writing one line of code.
Nice.
Because that
I can already see how that might exist.
You can see how that might exist.
Might.
So let us start with a while loop. Let's exercise with that a little bit. So let's create an integer called fun level. What is our fun level? And our fun level starts at 0. Because at first we're not having that.
You gotta start with somewhere.
You gotta start somewhere. Fun is a fixed number now. And I'm gonna run this code in setup just because I know that code only runs once. But this code can be run anywhere. Absolutely anywhere. In our draw, in any function we want. There's no differentiation there. So we have our fun level, it is at 0. So in our setup, I can say while fun level is less than 10. So I can say while our fun level is less than 10, I would like to print out the fun level. So what's going to happen here, Gabe?
It's going to print hello a bunch, isn't it? Oh, wait,
hello?
Sorry, I didn't know. I have hello written in mine, so I looked at that. So while fun level is less than 10, it's going to run it because fun level is 0. It's just going to run it constantly.
Constantly?
Yeah.
Yeah, you caught the bug I had.
Just a loop.
You caught the bug because what will happen is it won't run because the language is saying, like, well, even Chrome is frozen here. There we go. Exiting potential infinite loop. To disable loop protection, add no protect to the end of the line. Yeah, the language is saying, what are you doing? You're being silly.
I like that Chrome froze. It's just like
Chrome froze. But yeah, you caught it. We never change the number. It's always going to be less than 10. So what I want to do is I can say fun level is equal to fun level plus 1. And do you see what's happening here? So this
now
works.
We're giving fun. We're giving fun level value, so it can't go up to. Well, it goes up to 10 and then stops.
Yeah, it goes to 9.
It
kind of see it here. Kind of see 9 here. Yeah. There we go. And then it stops. Yeah, because
it stops the moment it doesn't fulfill the while condition.
Yeah. And you said,
is it a while condition?
Yeah, you can call it that. But do you see what's happening here? What is this guy in len 8?
It's telling it to add 1 every time. It's adding. Where are we going? We're going on an adventure back in time.
We're going on an adventure. Whoops. What's this?
It's the. No, I don't remember the name of it. I forgot. Sorry.
Yeah, but you see.
Yeah.
At the end of the loop, you increment the thing, or you do the incrementation. That's this guy.
Yeah.
That is why someone wrote a for loop, because they saw a while loop, that they were always doing this in a while loop. That's a common pattern. Let's create a feature in the language where you can just do this automatically in one line and you don't have to worry about it. I don't have to always put this thing at the bottom here. That's it. So a for loop
just replaces that.
Is not special in that way. It's just a while loop that does this for you. And it's actually just saying,
damn lazy people.
Yeah, it's doing this.
Yeah.
Remember, this is done once.
Yeah.
The condition is asked every time. Oops, go back. Yeah.
Yeah.
And then at the end, we increment the number. Yeah. So it's not that different.
Was it? Fearless coding is all about laziness. Yeah. Wasn't it? I think it was Bill Gates that said, like, he would rather hire a lazy person because they'll always figure out how to do something as fast as possible, or so. It was something along those lines.
I don't know.
Like I mean, maybe it's a bad way. I'm like completely butchering the whole thing.
You're on the right track. Yeah. I don't know if it was him or not.
But make things basically as efficient as possible, so people.
Yeah, I mean, you want a person that will automate stuff for you. I mean, you still want them to be competent and know how to do their things.
Sorry, Bill Gates, please don't come after me. I love Microsoft.
If the person is still productive and knows its stuff, then if you're lazy, you don't want to do the thing again. Oh, like I have to go thing and do a thing.
You make a way to make it efficient.
Exactly. Because then it's automated. You don't have to worry about it. And that's the thing I say often here is I don't want to have to worry about a thing. I'd rather get a solution that takes a little bit more time to do, but in exchange for it, I don't have to worry about it. Okay? So let's increase the fun level. Let's have a lot of fun over here. 10,000.
It's just going to keep going for a while.
Chrome is a little bit laggy now. There we go. At 2,797, it says you're being silly. Anyway.
But the point is still there.
Let's do 1,000. It runs up to 1,000. Yeah. So that works. That's great. Then let's mix those two together. Let's create an array. And let's have an array of fun levels. And then for every fun level, we put the number in. So instead of printing out the number to the screen, we're actually storing the data. So how was an array declared? That was the new thing you had?
Uh-oh. It was new brackets.
The brackets. And then instead of
the other brackets.
The other brackets. So instead of and instead of doing this, we say new
with the brackets.
It was int and then the brackets.
Yeah.
And what do we have to put in between?
The number of them, the total fixed value that we want.
Let's start with 10 to begin with. So now we have 10 integers. We have an array of 10 integers. The array is now called fun level. And how we access each one is with a bracket and then the number of the index. So now, instead of doing this, I would like to use one of the for loops. So I say for int I is equal to 0. Let me erase this for a second. I erased too much. There we go. So I would like to create a variable called I. And I would say I is less than 10. And I say I is equal to I plus 1. So this is the same loop as is in the presentation. Tell me when you are ready.
I am ready.
Great. I can actually use all the screen like this because I can.
Yeah, we had some technical issues with basically right before the stream, but it wasn't network for once. It was we've been
pretty good on the network today. Yeah.
We've had a bit of PC issues, so I broke one of the overlays, so that's why we're using this. You can blame me for that.
So let's just try printing this out, because that's always, we should do baby steps. We just wrote this whole for thing. Let's print ln and just the I, nothing else. I would like to print the variable. Then I hit play, and I will just get now here the list.
Uh-oh, I broke something.
You broke something?
Yeah, mine says an unexpected token.
Unexpected token. But why would you put a token it doesn't expect?
Oh. I might explain it.
Since I can't see his screen now, because I usually...
Can you usually find it real quick?
Insider info, I used to see his screen by watching the little monitor here. Yeah. But now, since the monitor isn't up, I can't see his screen.
You can see this. There you go.
There we go.
This is me. Where did I mess up?
You did it. Oh, it's a comma after the int I instead of the semicolon. So it's a semicolon, not a comma. So int I
here.
Mm-hmm.
Ah, yes.
And then, there we go. You should be happy then. Did you print out everything?
Print is not defined.
Print ln.
Yeah, here.
Print ln I.
Or did I mess it up?
You forgot with void setup. Can you increase the text size a little bit? Yeah, big L is a small L.
Oh.
There we go.
Good job, Gabe.
Yeah. You get the thing. Okay.
You can't see it, but
we can switch back to mine then.
I did it.
You're happy now. He did it.
Should I use the same size screen as yours? Yes, we'll go back to yours. We'll go back to the smart people.
Then we should stay on your screen.
No.
Okay. And as we learned before with arrays, an array stores the length. So I'm repeating a number here, 10 and 10. And I don't want to do that. So I'd say funLevel.length instead of the 10. And I can hit play, and I will get the same thing. So now I only need to change the number up here. And if I hit play, I will get
many numbers.
Many numbers. That's great.
Oh, I didn't like that. I added a few zeros.
A few zeros.
Yeah. Mine didn't go as high as yours. Mine only went to 2,543.
I have a faster computer then.
It's really? Is that what it is?
Yeah, sure. I don't know.
It shouldn't be. This PC should be better. Just saying.
Great. Okay. So now I have this I. That's great. Which I can then use, because if I do this, I would like to print to the screen funLevel of I. So what is going to happen right now?
It's going to print the same thing, won't it?
So let's go through this thing. So int I is 0. That happens once. First time around, I is not 0. Great. We ask the question, is I less than fun level length?
Yeah.
Which is 100.
Yeah.
Is it true? Is I less than 100?
Yes.
Yes. Great. We go into the code. We say, let's print to the screen the ith fun level.
So to start at 1, right? Or to start at 0?
Start 0. Yes. So we're getting fun level 0.
Yeah.
What's fun level 0? Have we set anything?
No.
No. So it's going to be 0 in this case. In other languages, it might be just junk numbers, but that's in this language, we can get a 0. So it'll just be 0. Okay. We've done our code. We go back to the end of the curly brace. This is executed.
Adds I, so
now I is 1. We go back up here. We ask the question, is 1 less than 100? Yes, it is. We go into here.
So it'll print the same thing.
Fun level 1. We haven't said anything.
Yeah.
So it's 0.
Oh, really?
Yeah, because we haven't set any. We just created the array.
Is it just going to print 100 zeros?
Bingo.
Oh.
Okay. Well, we want to set the value. And like we talked about before, this is an integer and this is the array. And if this is an integer like any other integer, then I should be able to do this. So when you're ready, let's talk about this. Because this is an important concept to figure out. So again, I is 0, it's less than 100. We go in and we say fun level 0 is equal to
I.
Which is?
0.
Yeah, cool. I print out
0.
Yeah. I go back down, increase this to the value 1.
But now we're telling it fun level is 1.
Yeah. So what will print out?
1.
And then what will print out if we go through the whole thing?
All the numbers up to 99.
Again, Gabe, bingo.
Nice.
Yes. But now, do you see the difference here? Instead of printing out I here,
yeah,
I'm printing out the values that we are storing in the array. So we are storing the numbers from 0 to 99 in memory. So I can then take this array and I can do this. I will delete this one. Now we're just setting the values. We're not printing anything. So if I hit play, nothing will happen because we're not printing anything. I will then create another loop here below, which is going to be the other type of a for loop. So let's call it int fun. So the variable is called fun. It is of the type integer. And instead of doing semicolon, we do colon, and I type in fun level. I will do my curly braces, and then here between them, if I scroll down a little bit, there, I can do println fun. So now let's go through this. At the top, I create an array of 100 integers. In the first part of setup, I have a for loop. And like we saw before, we are storing the numbers from 0 to 99 in memory. So now we have an array from the value from 0 to 99. Great. And then at some point, I will be 100. It will be at some point it will be 99. We'll store 99 into the 99th index. We will increment the number to 100. We will ask the question, is 100 less than fun level length, which is 100? Nope. We will exit the loop and we'll go down here. Now we have another for loop right after this one. This is the other kind of for loop where we have a collection, which is an array, and we create a variable, this thing will go through the collection automatically. We don't have to do all this jazz over here. And it will start at the first element, and then the second element, and the third. So for every loop in this one, it will just automatically go through each element. So what will be the first thing printed?
1. No, 0.
0, and then
1. So
it's going to do the same thing. And third time, bingo. So that is why we have those two types of loops. The first one is when you want to access the value here and to assign to it, because you cannot assign to this one and it will change in the array. And this one, if you just want to go through things and look at the values. So they both have their place. A for loop is basically a specific while loop, where if you created the variable before, and then you have like this iteration part at the end, and this one needs to have a container. Because we saw here, I could have just written 10. Oops. There we go. So in the top part here, there is no container. It's just variables. So we can actually loop without having to have some sort of containers or some sort of collection, sorry. But this one here needs the collection. So there are specifics to that. All right. And then next time,
next time,
we're going to use this magic.
Oh, snap. Make some enemies.
To create enemies on screen.
Pew, pew.
To move them around.
Then we're going to shoot them.
To create bullets.
We're going to create bullets next time?
So my idea is to create... The next episode would focus on creating bullets. Then after that, we can create enemies that will then get hit by those bullets.
Nice.
On the next Code School. Yeah, Phillies. All right.
Sweet.
Before we go, do we have any questions from chat? Because we were able to stream, and that is wonderful, and I'm really happy that we could stream it. 0 drop frames, not like last time. And since this is a kind of a different Code School, I'll save this. This thing here I will save that into the GitHub.
Just 1 dropped overlay. No frames, 1 dropped overlay. Hamish will have to come down here and work his magic.
Yeah, that's fine. I'll save these 14 lines here. So it won't be much in the GitHub, but at least if you're stuck or you think you have a bug, you can look at that. And of course, you can use the video to look at the presentation. And then we will not be next week?
Not be next week.
Yes.
So next week we'll have a little bit of a break, not even mid-season, but we'll have a little break off week. We might be back and do some other streaming. We'll maybe do some community Rainbow Six. So if you want to play some Rainbow Six, come back, be here. That's a maybe. We'll see. Content schedule will be out on Monday, but no Code School next week, so there won't be a VOD. And episode 7 will take place on December 7th.
So December 7th. So there will not be a stream next Friday, and there will not be a VOD next Monday.
Yes.
This VOD should be up on Monday after this
26th.
weekend, and we will stream on the
7th.
The 7th
of December.
Great.
Sweet. Thank you, everybody.
Thank you.
Bye.
Bye.